You have to define your variables, and how do you have to answer? With a sentence every time. Today we're looking at a slightly different type of problem. And I'm going to be teaching you a strategy for solving these more complicated problems. So it is very, very important that you stay with me today and ask questions if you get confused, because I'm going to use this same strategy for the next few days when we're looking at all these various types of problems. So let's look at example 4. It says how much pure alcohol should be added to 20 liters of 40% alcohol to increase the concentration to 50% alcohol. Okay, this problem has a lot going on. We have the pure that we're going to mix in with the 40%, and we want to get a 50%, right? So there's a lot of different pieces to this. What I suggest is on these problems, when you have so many different pieces, we make a table to keep our information organized. We're going to put a formula across the top of the table here in a second. My rows are going to be the things I'm mixing together. Now, I don't care how you label these as long as you know what they represent. What are the two things that I'm mixing together?
Pure.
The pure and the 40% to get my total, or to get my 50% mix. Alright, just a hint, on these mixture problems, you would, even if I didn't say, if I just give you 3%, you can always tell which one is your total. If I gave you like an 80%, a 20%, and a 40%. You always have to mix your highest and your lowest, and your total has to be something in between. Does that make sense? So out of 80, 20, and 40, which one would have to be my final mixture? 40, because it falls in between the others. If I said, 5, 7, and 10, which one has to be the final? 7. So sometimes if the problem's worded funny, people kind of question which one is the total. It's just the one that falls in between the other two. Okay, you have to mix your highest and lowest to get something in the middle. So now we have to figure out what we're going to put across the top. Today's problems are all going to be very similar, so once we do one of them, we'll kind of know. But we need to figure out what kind of formula we need to start with. If you look at the question, it kind of gives us some hints. I start out saying how much. So we need a column for the amount. Okay, I'm trying to find how many liters I need, so we need an amount. The next piece of information given in the problem, I talk about the pure and the 40% and the 50%. Those are your concentrations. Okay. A lot of times, if you're not sure about this step, if you just take a second and think about it, you can get to your answer. If, for instance, my daughter loves juice, but I think it has a lot of sugar in it and it's bad for her teeth. So the only time I ever give her juice, I add water to it and water it down. Okay, so if I give her, let's say a cup to drink, but when I mix that, I put in like 1/4 of a cup of water, or juice, and the rest water. So it's really only 25% juice. So she has 1 cup of liquid, but only 25% of it is juice. How do I find out the actual amount of juice in there? What would you do with those two numbers? Or if I said it was 2 cups of liquid and only 25% of that is juice. Okay, if you take 2 times 0.25, you get the amount of actual juice that I put in there to begin with. So our formula here, we're going to take the amount that we have times the concentration, and that equals, I call this the amount pure, the amount of actual apple juice that I put in her cup to begin with. Okay, this will be the same formula we're using on all of these, just your amount times your concentration equals your amount pure. Those are the columns in my table. Okay. Now if we start filling in the gaps. It says how much pure alcohol. So do I know the amount of my pure? Nope. So if we don't know it, we call it X. Should be added to 20 liters of the 40%. So the amount of my 40% is 20. Okay. So how would I get my total amount then? If I put in 5 liters of pure and 20 liters of the 40, how much do I have in my cup or whatever? You had 5 of one and 20 of the other? $25. We just add them together, right? So this down here will be X plus 20. Okay, concentration. If it's pure, what percent is that? 100%. When we put these in the percents in, we have to change it to decimal form. So 100% is just 1. 40% would be 0.4, 0.40. And the total was 50%, so 0.5. We've done the hard part. To get the amount pure, we just use our formula. You multiply amount times concentration. So X times 1 is X. This I'm going to do 20 times 0.4. You can go ahead and multiply it. I'm not right now, just so you can see what I'm doing if you look back at your notes. Last one, I have to take my 0.5 times the X plus 20. Okay. The nice thing about these, the equation kind of writes itself from here. We have the amount pure so that's the amount from the first one, the amount from the second one, and the amount in the total. So if you add the 2 you put in, you should get the one in your total. So all we have to do is add those first 2. And it will equal the total. So that's one of the real benefits of the table. The equation kind of writes itself. You just have to add them to equal. So now, let's solve this. So we have X plus 0.4 times 20. What does that give you? 8 equals, we have to distribute 0.5x plus 0.5 times 20 is 10. subtract the 0.5x. So we get 0.5x plus 8 equals 10. Subtract my 8. Divide by 0.5, and we get 4.
If you have negative 0.5, because you subtracted it over, right?
Right here? Well, this is like a 1x
Oh, yeah, so it'd be
minus 0.5. So it's like 1 minus 1/2. Other questions? Am I done? No, I always want you to write a sentence at the end. The question was how much pure alcohol. If I look back at my table, X was the amount of pure alcohol. So there must be four liters of the pure alcohol in the solution. Questions, right? Let's look at another one. How many liters of a 25% antifreeze solution should be added to 5 liters of a 10% solution to obtain a 15% solution? All right. So, again, we're mixing things. We're going to set up a table. All right, we have to look at the things we're mixing. If I don't even read the problem, I have 25, 10, and 15. Which one is the final? The 15. So my total is the 15%. So I'm mixing together a 25% and a 10%. Okay, formula. We start out, how many liters, so we need the amount, times, we have these percents, so the concentration equals the amount pure every time. Now, we just have to start filling in the gaps. So the question starts out, how many liters of a 25% solution? So I don't know it. So if That's my X. Should be added to 5 liters of a 10% solution. So the amount of my 10 is a 5. What would my total amount be? X plus 5. Concentrations. The first one would be 25%, so we put 0.25. 10% we put 0.1. 15% we put 0.15. Remember, with percent you move your decimal back 2. Now we just use the formula, multiply. So we have 0.25x. We have to do 0.1 times our 5. 0.15 times the x plus 5. From here we write our equation, and how do we do that? We have the amount in the first, the amount in the second, and the amount in the total, so we just add them to equal the total. This plus this equals that. So 0.25x plus 0.5 equals 0.15x plus 7.5. No, sorry, 0.75, right? Multiplied by 1.5 instead of 0.1. Okay, so now subtract over your 0.15x. So 0.1x plus 0.5 equals 0.75. Subtract your 0.5. Divide by the 0.1, and you get x to equal 2.5. So the question was, how much of the 25%? Looking back, that is exactly what x represented. Questions so far? I'm going to put another one up here. I want to give you just a couple minutes. I don't want you to solve the whole thing. I want you to just try to set up the table. And then we'll talk about it together before you get too far, so if you have any mistakes, we'll catch them. So we are doing a mixture, so we need our table. This time I'm mixing water with an 18% solution to get a 15. So my formula, amount times concentration equals the amount pure. Okay, starts out how much water, so I don't know that. Should be added to 20 liters of an 18%. 18% there is a 20. To reduce the concentration to a 15%. So what would my total be here? X plus 20. Okay, 15%, that concentration would just be 0.15. 18% is 0.18. Water. Let's talk about that. If you go out to the water machine there, how much acid is in the water that you're drinking? None, we hope, right? So what would my concentration be? 0. If something is pure, it's 100%. Water is 0. It doesn't have anything else in it. So then we just multiply. 0 times x is just 0. I'm just writing this out for the sake of the notes, but you can go ahead and multiply those. And then we know the formula is the same every time. You add the first two, add the ones you're mixing together to get your total. So 0 times x is just 0. We can get rid of that. 0.18 times 20 is 3.6 equals 0.15x plus 0.15 times 20 would be 3. If we subtract over our 3, divide by 0.15. And get x equals 4. You guys with me on all of that? So the question was just how much water? So there should be 4 liters of water. Okay. If it would be okay with you guys, the homework is going to be 3 problems just like these. Can I do maybe one last example, because we still have over 20 minutes, so I maybe do one last example that'll kind of lead us into Monday's portion, but I won't give you any homework like it, and then I'll be done. So last example of the day. This one is a little bit different. Sarah has $70,000 to invest and requires an overall rate of return of 9%. She can invest in a safe government-insured certificate of deposit, but it only pays 8%. To obtain 9%, she agrees to invest some of her money in non-insured corporate bonds paying 12%. How much should be placed in each investment to achieve her goal? All right. So this one is a little bit different, but we still have several things going on, so we're still going to use the table strategy. She's investing we have an 8%, a 9%, and a 12%. Which one of those has to be my total? The 9%. So we have the 8, the 12, and the total is 9. Okay, my formula across the top, it's not going to be the same as the others because I don't have an amount and a concentration. I'm talking about interest here. How do we calculate interest? I know you've done it before. Yeah. I equals PRT. Interest is equal to the principal times the rate times your time. Okay, so we're going to use that formula here. So I'm going to do a P times R times T equals I. I want my I at the end. So we have an extra column, but we're still just going to fill in the gaps. She has $70,000 overall. Is that the amount she has for 8%, the amount for 12%, or her grand total amount? It's all she has, so it's got to be the total. It's total principal, your total starting amount. So she's going to put some of her money in each of these other two things. Now here we have to be a little careful. I can't just say they're both X, because it says she puts the same amount of money in each. No. So I'm going to make one of them X. Now let me ask you a question. If she has $70,000 and she put $10,000 in the first, how much would she have to put in the second? 60. How did you get that? You subtracted them. So for my 12, it'll be 70,000 minus X. Her total minus the amount she's already spent. The rate, 8% would be 0.08 because you have to move the decimal 2 places. 12% is 0.12. 9% is 0.09. Okay, does it make any mention of how many years she's doing this investment in the problem? No. So we're just going to make our life easy then and do 1 year. So then we just multiply. So X times 0.08 times 1 is 0.08X. Now 0.12 times 70,000 minus X. And the 0.09 times 70,000. The formula, just like the last one, the equation, you're just adding the ones you're mixing together to equal the total. So add the first two. To equal your grand total. Start working this out. I have 0.08x plus 1,400 minus 0.12x like terms. 0.08 minus 0.12 is negative 0.04. If I subtract over my 8,400, and then divide by the negative 0.04, you get 52,500. The question was, how much should she put in each investment? So X was the amount at 8%. So she needs $52,500 at 8%. And to get my 12%, you have to do 70,000 minus X. So 70,000 minus 52,500. Questions? So yesterday I posted a handout, and section 1.6 assignment, you should have already done 1 through 4. We're just going to add this onto that. So now we can do 5 through 7. So you've got 3 problems. So you can just do it on the same sheet of paper, and you've got the rest of class to work on that and ask if you need any help.